Okay, Algebra 2 fans, our topic for today is solving polynomial equations, finding the zeros. And before we start, let me give you your joke of the day. What did the cake say to the fork? Want a piece of me? All right, now a lot of this can be done using a graphing calculator. Okay, so we're going to use the calculator a little bit, but I'm also going to show you how you could use synthetic division, which was our last topic. So, solving polynomial equations, finding the zeros. First question, is x equals 5 a zero of the function f of x equals x squared minus 3x minus 10? The easy way to do this is to take 5 and plug it in and see if you get a value of 0 out of that. So f of 5 is going to be x squared minus 3x minus 10, and we're going to substitute a 5 for the x's, so you get 25 minus 15 minus 10. 25 minus 15 is 10, minus 10 is 0. So is 5 a 0? Yes, it is. So x equals 5 is a 0. But the other thing that we can say, that means that x minus 5 is a factor. What we're going to try to do is factor some of these polynomials and see if that will help us find zeros. Okay, so the next section here, directions. Graph the following functions on the calculator and use synthetic division to determine the zeros of the function. We're going to use the calculator to start us off, okay? And if I go to y equals, and I'll go back to this function here at the top, x squared minus 3x minus 10. If I graph this, zoom 6, one of the zeros should be positive 5, and it is. Okay, if I go to the table, and I go to, well, actually, let me change the setup. Okay, so when x equals 5, the y value is 0. Okay, so 5 is a 0 for that. So you can use the calculator to find some of your answers. The problem is the calculator won't find all of them necessarily. Okay, so in number 1 here, f of x equals, and we have this big polynomial, third degree, x to the third is the lead term. Graph the following functions on the calculator, use synthetic division to determine the zeros. Okay, so let's graph this first. So we'll go to y equals, so 2x to the third plus 15x squared plus 18x, and then minus 35. Okay, I'm going to go zoom 6. It's probably not going to show me all of the local maximums and minimums. It does show us the local maximum right there, but obviously the minimum is somewhere down here. All right, now it looks like we have 1, 2, 3 zeros, which makes sense because if it's a third degree polynomial, you should have 3 zeros. Now in this case, they're all going to be real. Sometimes you may have imaginary, so don't forget about that. Now what we'd like to do is find a zero that has a integer value. That's going to be the easiest situation. So if I look at the one on the left here, that looks like it might be negative 5. Now I'm not going to assume that. I'm going to go to the table and I'm going to look when x is negative 5 and see if it gives me a y value of 0, and it does. So right away I have a solution, negative 5. Now I have 2 more solutions though, and actually if I look at this, here's another one down here, 1. But let's say we don't know that. So what we're going to do here, since I know that negative 5 is already one answer, I am going to use synthetic division to try to break down this cubic equation. Because one thing that we know is that if negative 5 is a 0, then that means that x plus 5 is a factor. X plus 5 is a factor. And if that's a factor, it should be able to divide into this evenly. So I'm going to write down the coefficients, 2x cubed, 15x squared, 18x, minus 35. So with synthetic division, the 2 comes down. We multiply. 2 times negative 5 is negative 10. Add these up, that's 5. 5 times negative 5 is negative 25. Add those up, we get negative 7. Multiply, you get positive 35. Add them up and you get 0. Now, we were expecting this because if this is a 0, if this is a solution, then when you evaluate it, you should get 0 at the end. Now, the reason we did this, okay, yes, negative 5 is a solution. I'm going to keep that. We did this so we could break down and find the other polynomial that we can multiply by x plus 5 to give us this. Now, this would be 2x squared. This would be plus 5x, and then the constant minus 7 is going to be the leftover part of this. So you've got x plus 5 is a factor, but so is 2x squared plus 5x minus 7. That's your function. Now what I want to do is set this equal to 0 and see, can I solve this part? Can I solve the trinomial? We've already got this solution, that was negative 5. So I'm going to take 2x squared plus 5x minus 7 and ask myself, can I make that equal to 0? Now you could do quadratic formula. You could graph it and find the zeros, which is kind of what we did to get negative 5. I'm going to factor because I know that this will actually factor. So if I use factoring, I would do 2 times negative 7 on the side, which is negative 14. So I'm looking for numbers that multiply to negative 14 and then that add up to the middle term, which is 5, the middle coefficient. In this case, it'll be positive 7 and negative 2. 7 times negative 2 is negative 14. 7 plus negative 2 is 5. So if I do this by grouping, I would get 2x squared. I'm going to say minus 2x. I'll put that first, and then plus 7x minus 7 is equal to 0. So I've just changed the way the 5x looks, the middle term. Group it, so that's 2x times x minus 1. And then here I'm going to factor out a positive 7, which leaves me x minus 1. So I get x minus 1 times 2x plus 7 is equal to 0. Now I can solve it. So I take each factor and set that to 0. This will be positive 1. Now this, I would subtract 7, and then I would divide by 2. Now those are going to be my 3 solutions. Negative 5, positive 1, negative 7 over 2. And if I go back to my graph, if I look at it, here's negative 5, here's positive 1, and this looks like it's between negative 3 and negative 4. Negative 7 halves is negative 3.5. So I'm fairly confident that I've done this correctly. And now what I'm doing, this is how I can use synthetic division. Now like I said, there may be an easier way if you just use the calculator. But if you want to use synthetic division, this is what you would do. Okay, so our 3 answers, I'll write it as a set, as a solution set. So we have negative 5, negative 7 over 2, positive 1. Now you're thinking, why would I do it this way when I could probably use the calculator? Well, let's say we do something like number 2. Okay, first thing we'll do is we'll graph it and see what that shows us. Graphing it's going to give you an idea of how many real zeros you're looking for and also the types of zeros. Zoom 6. Now it didn't show us very much. Looks like the graph comes down here. Looks like it hits the axis and it comes back. It looks like it hits at x equals 1. If I go to the table, let's see. Okay, 1 comma 0. 1 is a solution. Now the other thing about this though is since it looks like it bounces off, that is a double 0. So what that means is that 1 is a solution twice in this equation. Now here's how I'm going to do that. I'm going to use 1 to break this down. Okay, now I'm going to go through this a little bit faster, so feel free to pause this if you want to do it yourself. I'm just verifying negative 26, 1, whoops, 6 plus 6 is 12, excuse me. 12, 14, 14, negative 12. Okay, I'm messing up here. 1 times 1 is 1. 6 plus 1 is 7. 2 plus 7 is 9. 9 times 1 is 9. Negative 26 plus 9 is negative 17. Okay, now this is what happens when you rush. So I should probably slow down. Okay, so 1 is a solution. Now what it does is it breaks this down. Negative 17 is the constant. 9x is the linear term. 7x squared is the quadratic, and then this is 1x to the third. Now the thing about this is that since the 1 is a double zero, I can actually use that value twice. So what I'm going to do now is I'm going to use the 1 again. Now I can only do that because this is a double zero. All right, now let me do this correctly. 1 times 1 is 1. 7 plus 1 is 8. That's 8. Add that, that's 17. Plus 17, okay, is 0. So again, I get the same solution twice, and you're thinking, well, what was the point of that? Well, the point is to get this down to a quadratic function, which would be x squared plus 8x plus 17. So if I write out the factored form here, that's not going to factor actually. There's nothing to multiply to 17 that adds up to 8. Doesn't mean I can't solve it, it just means I can't factor it. But if I wanted to rewrite this this polynomial, the factors would be x minus 1 twice, okay, squared, times x squared plus 8x plus 17. Now I want the solutions, but you notice on the calculator, we only see the 1 solution, the double root at 1. What that means is that if I solve this equals 0, I'm probably going to be getting i's is my solution. I'll get imaginary numbers. So to solve this, I'm going to do the quadratic formula, where a is 1, b is 8, c is 17. So x is equal to, it's the opposite of b, plus minus the square root, b squared minus 4 times a times c, all divided by 2a. Okay, again, I know I'm going through this fast, so please pause if you want to work it. Negative 8 plus minus square root, that's 64. This will be minus 4 times 1 times 17 is negative 68, all over 2 times 1 is 2. Keep going with the radical, that will be negative 4. The square root of negative 4 over 2. Now what happens, that's not a real value. What I have to do is I have to poke out my I. The square root of negative 1 is I. Now the square root of 4 is 2. So I've got, this is negative 8 plus or minus 2i over 2. There's no more radical because the square root of 4 is a perfect square. Last thing, I can divide each of these by 2, so I get negative 4 plus or minus I. Now I get 2 non-real solutions. I get 2 complex solutions, and I get 2 real numbers. So I get a total of 4 zeros, which I should because my lead term, my degree is 4. But 2 of them end up being imaginary. Now this leads us to a theorem. It's called the conjugate pairs theorem. Let f of x be a complex polynomial whose coefficients are real numbers. If a plus bi is a 0 of f, then the conjugate a minus bi is also a 0. That has to be true. If you have one real 0, this was negative 4 plus I and then negative 4 minus I, you have to have a second complex 0. You can never have just one. So they always come in pairs. So if you know that one of them is a 0, so is the conjugate. So for number 3, the degree is 4, so you should have 4 answers. 3 plus 2i is an answer, so you already know 3 minus 2i is an answer. And then 4, multiplicity 2, what that means is that you get the same thing twice. Now you wouldn't list it twice, but here are your 4 zeros. Okay, so go ahead and do number 4. I'm going to stop the video and then we'll go part 2.